This is problem 1-72 on page 43. A mercury manometer, and they've given us a density here, so let's jot it down. 13,600 kilograms per cubic meter for the density of the mercury, is connected to an air duct to measure the pressure inside. The difference in the manometer level is 15 millimeters and the atmospheric pressure is 100 kilopascals. Judging from the figure, which is below here, determine if the pressure in the duct is above or below the atmospheric pressure, and then finally determine the absolute pressure in the duct. So the duct looks something like this, and the manometer comes over, down, up, and the manometer deflection looks like this. So here's the mercury in the tube, and the deflection is this dimension here, 0.015 meters. So that's 15 millimeters. And so the air is flowing this way, and the pressure is the question. Now, you should be able to look at this and determine whether the pressure here or the pressure here, which is the atmospheric pressure, which one is higher. Well, since the mercury is deflected off to this side, apparently there's more force pushing on this side than there is on this side. Right, so the pressure on this side must be higher than the pressure. If the pressure on this side was higher, it would deflect the other way. Right? So the pressure that we get here, we know is greater than atmospheric pressure, just by looking at the deflection of the manometer. But now the question is, how much is that pressure? And we're asked to find the absolute pressure. Yeah, the absolute pressure in the duct. The atmospheric pressure was given to be 100 kilopascals. And so all we have to do is look at this, realize this represents the pressure on this side that's above the atmospheric pressure, and so we'll add it then to the atmospheric pressure to get the total pressure inside. So that would be pressure equals atmospheric pressure plus the deflection pressure, if you will, which is just rho GH. And so 100 kilopascals plus 13,600 kilograms per cubic meter multiplied by 9.81 meters per second squared times the height, 0.015 meters, will give us the answer. We've got a small problem here, though. That's a units mismatch. This first term has units of kilopascals. Let's find out the units of the next term. A kilogram times a meter per second squared is a newton. So that takes care of those terms, or those units. A meter per meter cubed is 1 over meter squared. That takes care of those. A newton per meter squared is a pascal, and you can't just add kilopascals to pascals. It's like trying to add 1,000 inch to 1 inch. It doesn't work. You have to have the same unit. So basically what we need to do is divide this by 1,000 pascals per kilopascal, and that'll make the units of this overall term kilopascals. If you're confused, it's because this is a fraction, and the kilopascals is in the denominator of the denominator. So you invert and multiply, and the kilopascals will end up in the numerator. All right, so one way to do this, we can cross this off and just make this a decimal point, and that will allow us to get our answer. So let's find out the result. We'll plug it in our calculators. See what we get. 13.6, so I have to type in that 1,000, times 9.81 times 0.015. Plus 100. Looks like the absolute pressure is 102 or so kilopascals. So there's the absolute pressure in the duct.